Okay, we're live. So hello, everyone. I'm Kareen Wallach. I run developer marketing and community at Startree, and I will also introduce the presenter for you guys shortly, in a moment. We are trying out a new kind of system of streaming. We were using Zoom before, and now we just started using StreamYard with YouTube. So the cool thing about StreamYard is it actually lets you broadcast to like a bunch of different places. So we could do like Twitter broadcasts, and we could do it on YouTube and some other, sources. So that's pretty cool. But we would love to like get your thoughts on this afterwards, like what your experience was like. And we apologize in advance if there's any like technical difficulties or you see us really struggling to figure out how things work, because I think that's just going to be the nature at hand. And yeah, we're going to be starting momentarily. This is a cool feature on the StreamYard thing that allows you to highlight stuff. So yeah, I mean, I think we can kind of just get started. So this is going to be the intro to Pinot meetup. I'm going to give a little bit of an introduction to Chinmay. So Chinmay Soman is currently an engineer at Startree. Previously, he led the streaming team at Uber for building a large-scale self-serve platform around messaging, stream processing, and OLAP technologies. And before that, he worked at LinkedIn and IBM, focusing on distributed systems and security. He is a PMC member of the Apache Samza and also part of other open source projects, including Apache Pinot, as he is a committer, uReplicator, and Athena X. So thank you, Chinmay, for joining us and taking the time.
Thanks a lot, Kareem. I appreciate that. Do you want me to start the talk right now, or do you have anything else?
Yeah, we could start. I just want to give everyone a note. If you guys have any questions or anything like that, feel free to post it in the YouTube. I think that if you're using YouTube streaming, like live streaming for the first time, it says create channel. It's literally like 2 buttons to be able to ask a question live. We will have some of our team members there that will be able to answer questions as well. So yeah, so I'll hand it over to you. Okay.
Awesome.
Thanks,
you so
Chinmay.
much. And then you can see the full screen, right? I just want to make sure.
Hold on. I'm going to see. I think. Yeah. Wait. Like you mean that they can see the full screen? Are you sharing anything yet?
I am sharing. Yes.
Oh, hold on. I have to. Oh, here we go.
Yeah. Okay.
I see. This is the part of the technical difficulties where I was like, I'm not really sure.
I'm glad I asked. Otherwise, people would be staring at my face for the whole. Awesome.
All right. Cool.
Thank you so much. Okay.
All right. Thanks, Chinmay. We'll see you very shortly. I will also be posting some resources for Apache Pinot, including our Slack channel if you want to join. Please start the GitHub if you like it. And yeah, some other resources and stuff too. So, all right, Chinmay, take it away.
Great. Thank you so much. Let me make sure. Okay. All right. Thanks, Kareen, again, and welcome to everyone. This is an intro to Apache Pinot. So we'll be discussing a high level, what is Apache Pinot, and I'll also go through a little bit of internals on how it works and how do we get all the performance from Pinot. Okay, we can skip that. So I'll begin by discussing the use cases of real-time analytics. Actually, hang on. This is the thing with StreamYard. Let me quit my Slack. Sorry about that. Okay. So I'll begin by discussing use cases of real-time analytics and all the intricacies of and all the complexities of the requirements thereof. I'll give you a quick overview, introduction to what is Apache Pinot and how it fits in your data ecosystem to solve all such use cases. We'll also look at an in-depth view of the different components of Pinot and how they work together in its distributed architecture. And finally, we'll see a demo. Well, we'll have an end-to-end demo by ingesting some data and querying it via some SQL or even via Superset. Okay, so when we say real-time analytics, it actually there's lots of different categories of use cases that belong in this area. And we'll go through some of this in our slides. The most important category is known as user-facing analytics. And this is where you expose your analytical abilities directly to your customers or end users. So here's one example from LinkedIn, which is who viewed your profile, where you can view the historical stats on your profile views. Another one is feed relevance, which in this use case, every time you visit the LinkedIn homepage, we want to make sure you're not seeing the same thing again and again, and the feed is relevant. In other words, for any given story or content, we want to figure out how many times has this been seen by a particular user in the last 14 days or so, which can be done with a SQL query, something like this. And it seems straightforward. You're doing a simple aggregation with filters and a group by. But keep in mind, this query will be executed on a large user base, 700 plus million LinkedIn members. And this is executed every time someone visits the homepage, which translates to multiple tens of thousands of queries per second. So this is the requirements here are definitely non-trivial. In addition, we want to make sure the query returns quickly in the order of milliseconds. Otherwise, it's going to end up in a bad user experience. Here's another example of user-facing analytics. This is a dashboard that Uber Eats offers to the restaurant owners across the globe called Restaurant Manager. And this tool shows multiple things. The sales view of real-time and historical view of the sales metrics, the menu item feedback, and more importantly, the missed and the inaccurate orders, which lets the owner take some action in real time. And again, you can imagine the requirements are again non-trivial for building something like this. We're talking about half a million restaurants around the globe, and every time this dashboard is open, there's lots of SQL queries that we need to execute. So we're looking at multiple hundreds of queries per second on the underlying system, and each of this query has to return very, very quickly. So now let's move on to the second category, which is business metrics. And this is where we want to identify key indicators of your business that will affect overall performance. For example, for LinkedIn, it could be something like page views, so the count of page views across multiple dimensions. And more importantly, with business metrics, it's important to identify anomalies with such metrics. So for example, this shows a case where the page views suddenly dropped on a week-over-week analysis. And this is something we want to identify quickly in real time. Taking one step ahead, we also want to identify why that anomaly happened. In other words, which dimension or combination of dimensions led to the drop in page views. And doing this in real time is again very important for the business to fix such issues quickly. And finally, we have dashboards, which everybody has seen before in one form or the other. It lets you visualize all your important metrics in one place, and often also helps in triaging issues and even fixing issues in some cases. And you can imagine, this can be arbitrarily complex. To build a dashboard like this, you will be executing complex analytical queries on the underlying system to get all these insights. So the QPS and latency in dashboards can also be non-trivial. So taking a step back from all such use cases, we start seeing some patterns. For one, there's a lot of value in analyzing each individual event as it's being generated in real time. So for example, in case of Uber, knowing what the riders or eaters are looking at right now, the eyeball metrics, is very important. It gives you an idea of the overall demand, the demand metrics. It lets you predict what the user might want, and so on. And so there's a lot of value in these individual events. At the same time, there's also a lot of value in looking at an aggregate view of the historical metrics. And this could be sales metrics over month or years, and lets you make better decisions. So in all these use cases, both these analyzing individual events and historical events, both are important. If you also look at how real-time analytics evolves in most companies, typically it starts over here with a simple use case of monitoring your metrics. And this is where operators or operations personnel are monitoring these dashboards on a day-to-day basis. As the business grows, you bring in your data scientists and more engineers and start deriving business insights. So you're doing more complex queries and identifying these insights, again, in real time to make real-time decisions. And then some companies like LinkedIn and Uber have started to monetize this capability by exposing it directly to customers. So for example, Uber will expose it to restaurants, who are the customers, and LinkedIn will expose this directly to all the LinkedIn members who are all the users of LinkedIn. And this is the most powerful form of real-time analytics, and it's obviously transformative for the business. Now, different companies often use different technologies to implement each of these each of these different types of use cases. But we strongly feel all you really need is one platform called as Apache Pinot. So for those who haven't heard of Pinot before, Apache Pinot is a distributed, open source distributed database which can ingest data from a wide variety of sources such as Kafka or data setting in S3, HDFS, GCS, and so on, and then make it available for querying in a fast manner. At the heart of Pinot is a column store, and it also features a wide variety of rich indexing techniques and pre-aggregation techniques that allow you to do very high QPS queries in a low latency manner. So it's a great fit for building a wide variety of real-time analytical use cases that we saw before. In fact, all the screenshots that you saw were actually built on Pinot in LinkedIn, Uber, and other companies. Pinot is a mature technology today, and it's being used by big companies all around the globe. And some of the largest Pinot clusters can ingest at a very high rate, upwards of 1 million events per second, and can support multiple hundreds of thousands of queries per second, while still maintaining a low query P99 latency in the order of milliseconds. If you haven't seen the recent talk from Stripe, where Shauman and Joey presented their setup, their Pinot setup in Stripe, it's actually even more than this number. So I highly encourage looking at the Kafka Summit talk from Stripe. It is fantastic. Okay, so let's switch gears a little bit and look at the internals of Pinot. And just before discussing that, let me show you how Pinot typically fits in your data ecosystem. So we'll take the LinkedIn as an example here. So LinkedIn, whenever people visit LinkedIn and interact with the different features, that generates a lot of data continuously, right? So all the event data, which could be somebody viewed a content or somebody clicked on one of the buttons, all these events are being sent to Kafka. And then all the entity data, this could be the profile information, any of the company information, all entity data is typically stored in some OLTP store, like MySQL or Postgres. Of course, LinkedIn has a much more complex solution for this. But for this example, let's assume it's any standard OLTP solution. Now, all this data is is continuously archived in HDFS for a variety of reasons. This could be backfill, machine learning, and all complex typical batch analysis use cases. At this point, Pinot can, as I mentioned before, Pinot can ingest data from both Kafka and HDFS, and then make it available for serving all such use cases that we saw before. So let's look at what exactly is inside. When I say Pinot, what is happening inside? So all the data coming from Kafka and HDFS is organized in a columnar format and spread out across what we call as a Pinot server. So the Pinot server today hosts the data in a column format locally inside each server. Then we have something called as a Pinot controller, which is really the brains of the cluster, and it takes care of cluster membership, figuring out what data is located on which server, assist the query routing, and all the control plane operations of Pinot. And controller is using Apache Helix, which is a layer around Zookeeper to manage all this coordination. And finally, we have what we call as a broker, which can take the queries from the user or the application and then do a distributed scatter gather across the servers to resolve the queries. It's important to note that Pinot supports a Lambda architecture. So while we say there are two different data sources, oftentimes they're treated as one logical view to the user. And we'll see this a little bit more in the demo as well. So just to understand, going one more level of detail in how the data is distributed, let's take an example of a real-time data flow of Pinot. So in this setup, we have four Pinot servers. We have the one Pinot controller and one Pinot broker. And let's assume we want to ingest from a Kafka topic with 4 partitions, as shown by the different colors here. So the minute we set up a Pinot table to consume from this topic, the controller will fetch the Kafka metadata and discover that there are 4 partitions. So it assigns 4 different segments, one for each partition, and assigns it to a particular server, as shown in this map here. And this is what we call as a routing, internally called as routing information, and is stored in Zookeeper using Apache Helix. So the minute this map is created, the 4 servers are notified that they now need to start fetching the actual data from Kafka. So for example, the server S1 will start fetching from partition 1 and create a local segment called segment 1, right? And so on and so forth. Now, with any good distributed system, we want to make sure data we're highly available and data is replicated. So let's configure a replication factor of 2 for our table. The controller will take that information and then ensure that each segment is assigned to 2 unique servers. As you can, we have updated the map with that information. Subsequently, the servers will start fetching data in parallel from the Kafka servers. So at this point, data is flowing from Kafka partitions to the respective Pinot servers and being created as a local segment in each of these servers. So now let's see what happens when you get a query. And so when a broker gets a query, something like this, it will first fetch this routing information and identify what segments it needs to satisfy the query. And in this case, we need pretty much all the segments. At that point, the Pinot broker will send the query to each individual server. And the server will do a local query execution for the local segments. The resulting intermediate result is sent back to the Pinot broker, which does a final aggregation, and the response is sent back to the client. So this is what we mean as a distributed scatter gather. And you can see that this it's a great setup for a scalable distributed system. If you ever run out of capacity, all you need to do is add one more server, and then the controller will start assigning new segments to the new servers, and the broker will automatically discover all such new instances. So this was the real-time flow. Let's quickly look at the offline flow, which is slightly different in terms of how the data is ingested into the servers. So let's imagine there is some raw data sitting somewhere. This could be HDFS or S3, pick your system of choice. And we want to ingest this into Pinot. So typically in an offline use case, we rely on some framework such as Spark or Fling or what have you to convert the raw data into Pinot segments. And then these generated segments are stored in a well-known location known as a segment store. At this point, the controller can be notified, hey, I've generated all these segments. And then the controller will instruct the servers to directly fetch the segments over from the segment store. So in this way, the task of generating segments happens completely outside of Pinot, and we simply copy it over, which is much more efficient than the real-time flow. So naturally, this is the method of choice when you want to bulk upload data into Pinot. Recently, we have also added an ability in Pinot where you don't need to rely on an external component. You can just configure your table to read from a well-known location, and a background Pinot task will take care of segment generation and copy into Pinot. Now, once the segments are available in the server, the rest of the stages are the same. The Pinot broker still does the same thing, which is get the routing information and do a distributed scatter gather across all the servers. So let me talk a little bit more on the segment, since that may not be clear at this point. Right? The segment is a subset of the data that is being ingested into Pinot. So for example, here's a sample subset of raw data that we want to convert into a segment, say 1, right? And segment forms the unit of partitioning and replication, as you already saw. So the first thing the server does when it gets this raw data is to convert it in a columnar format, right? So what that means is, in this particular example, all the country location is grouped together, all the browser location is grouped together, and so on. For those who are not familiar with the benefits of columnar format, let's take a quick example where you want to do a count star where country is US. So in a row format, if you were to execute this query, you would end up scanning all the rows and then filtering those with the country is equal to US. In a column-based format, you still need to scan here, but you only need to scan one column. So the amount of data that you need to process is much lesser, leading to faster query execution. Of course, as I mentioned before, Pinot features a rich collection of indexes, and you can specify any type of index on any of these columns. So for example, to speed the queries up even more, we can define an inverted index on the country column. So instead of scanning, we can now just look up the rows which have US as the country. Similarly, you could also use a sorted index or something known as a star tree index. So star tree index, and this is actually how our company is named, is our most powerful index, which lets you pre-aggregate values for your dimension or a combination of dimensions while still maintaining a low storage overhead. So in this particular case, this query can be executed by looking up one single value. It becomes extremely fast for such cases. And this is just 3 examples what I've shown here, but there's lots of other indexes that I'll discuss later on in the slide. For example, we have text index, the geospatial indexing, and so on. And the architecture of Pinot makes it easy to keep adding such new indexes since everything is pluggable. And one more point on the indexes, typically you would configure these indexes at the time of table creation, but in practice, you can add an index at any point in the life cycle of your table. And all these new indexes are automatically reflected in your Pinot tables. Okay, so hopefully that gives you a quick idea of what Pinot is and the internal components. And let's look at a demo to make things even more clear. So make sure, okay, so you can see the terminal. So in this demo, we are going to we'll start a Pinot cluster, and then I'll begin with a real-time example. And I'm using the example from the GitHub event stream recipe, which is already available in the open source. So as a part of this quick start that I just launched, we set up the quick start will be setting up a Pinot cluster, which starts up all the components that I mentioned before, including zookeeper, controller, brokers, and servers. It also will set up a Kafka cluster for our real-time use case. And then finally, it will fetch real events from GitHub and publish them into Kafka. So let's assume this cluster is up. Let me see if, okay. So this is the Pinot cluster manager UI that is shipped with open source Pinot. And it's a great place to look at all different things related to Pinot. So for example, the home page will show you, your topology. So you have one controller, one server, and one broker. And then you also have one table which was auto-created as part of the quick start recipe. So let's look at the schema for this table. So as I mentioned, we're looking at the GitHub events, and the schema has a bunch of dimensions related to that data, such as the title, labels, the assignees, authors, and so on. It also has a number of metrics related to that data, such as number of commits, authors, and so on. And finally, we have one special column called merge time milliseconds, and we are treating this as our time column, which is important for a variety of reasons in Pinot. So with this schema, the recipe has created a real-time Pinot table with the same name. And you can see the sample table config that was generated as part of this demo. So there's lots of things you can configure in your table. For example, the retention that you want for your data. In this case, we are keeping it around for 60 days. The table replication that you want, and even the indexing config. So in this case, we are creating an inverted index on 2 columns called organization and repo. So any queries that filter on these columns are going to be very fast. And finally, we have the stream config here, which gives you the ingestion properties. So in this case, as I mentioned, I'm using a built-in Kafka cluster. So it's using the local Kafka cluster and the local topic to ingest all the GitHub data. So now that the table is created, we can just start querying it. As you can see, this is a simple select star. And these are real events fetched just now from GitHub as we are talking. So you can do any kind of SQL queries at this point. I'm trying to, if we get lucky, you can see this number increase a little bit since it'll actually fetching data from GitHub. Looks like we'll have to wait a little bit. But this is a simple example, and you can definitely try it on your own. available on our Pinot documentation. The one command gets you play around with Pinot very quickly. Okay, it's really not moving. Okay, that's fine. So this is great, but let's extend this demo to also add an offline table. So as I mentioned, our Pinot demo fetch data from GitHub and it's ingesting in real time. What we can do is also add some batch events into an offline table. So for example, these are events from the same GitHub API, but fetched about a month ago. And let's assume this is sitting in some place like HDFS or S3, in this case, a local JSON file. So what we will do is create an offline table to ingest this data into Pinot. And we'll see how that's viewed from the user side. So first and foremost, let's go and add the offline table. And we'll be using the same schema for the offline table because we want both real-time and offline to be treated as one logical view from a user point of view. So let's add an offline table with the same name. And this automatically fetches the same time column, which was specified in the real-time table. We'll keep the replication as 1 since we only have one server. There are additional properties that you can specify, such as the ingestion rate, and we'll skip that for now. This feature lets you configure indexing for your table. So let's go ahead and add that. So let's stick to what we saw in the real time. So we'll create an inverted index on the organization column and specify that we need it to be dictionary encoded. Similarly, we'll also create an index on the repo column. So this is the same thing as what we saw in real-time table. And then there's some more fields, such as if you want to partition your data, which often speeds up the queries in some cases. You can specify optional data retention for your table. We can skip that. And also things like, if you want to enforce quotas for the queries of this table. So all kinds of things can be configured. And then you can see how they're being reflected here in the offline table. So let's go ahead and create that. So as you can see, there are no segments currently. This offline table does not contain any data because we haven't pushed anything to that yet. And I actually forgot to show one thing. So this was the segments view from the real-time table. So you want to now populate data in the offline table. So let's go ahead and do that. This, as I mentioned, you can either use the built-in framework or use an external framework for doing this. For this demo, I will use an external tool to convert the JSON data that we saw, create segments, and then push it into Pinot. So it's going to read all the JSON events, look at the schema that we want for the table, and start creating segments, and then finally push it into Pinot. So we'll give it some time. So as you can see, it's actually creating indexing and then internal data structures relevant for the segments. And then sure enough, we just pushed some data into our offline table. Right, so now we have a real-time table which is fetching data from the GitHub API, and we have an offline table where we bulk loaded some events from a few months ago. But the cool thing about this, as I mentioned, this is treated as one logical view to the user. So from a query point of view, you just query it using the name without specifying real-time or offline. And then Pinot will do the job of combining the two tables when answering queries. So for example, if I do count star now, I see a significantly higher number in which is a combined view of the real-time and an offline table. Okay, so and you can see this is growing. So this is where you can see the real-time table is still getting more data. So this is cool. You can do all kinds of queries using the built-in SQL editor, but we can also integrate Pinot with all kinds of visualization tools. And I will pick Superset as one example here. For those who are not aware, Superset is an open source technology that lets you visualize data and slice and dice your dimensions in a very intuitive manner. So let's go ahead and connect Pinot and create the data set that we just created in Pinot. So we'll use the same, we only have one table right now. We'll go ahead and add that as a data set in Superset. One step that we have to do right now, which is still manual, is to inform Superset which of the dimensions is actually a time column. And again, this is important when you visualize the data, as you'll see later. And it'll also let Superset know what is the format of the time column. And in this case, the GitHub event, I'm using epoch milliseconds as the format. So I'll configure that in Superset. And now we are ready to visualize the data that's available in Pinot. So let's configure, use a line chart, and then use a custom date time range. Let's say 1 year before until now. So this is a simple count star of the number of of the total GitHub events that we saw over time. Right, and you can see that you can add all kinds of things to Superset to build a dashboard. So let's show one more example. Let's say we want to do a bar chart, identify the repositories in GitHub with the most number of commits, and we'll stick to, let's say, Apache, all the Apache projects within GitHub with a very high commit rate. So let's configure a bar chart, and then in this case we want a summation on the number of commits. So that's our aggregation function. Let's filter where the organization is Apache. So we're sticking to all the Apache projects. And then we want to group by on the repository here. And there we go, right? So it's able to query Pinot and build this visualization, and this sort of gives you a stack rank of the most Apache projects with the most number of GitHub commits. And again, this is all happening with respect to Pinot. So as more and more data comes in, this dashboard will keep changing along with the real-time data. Okay, so what we saw is a demo of both the real-time flow and an offline flow, and how Pinot makes it transparent to the users. So they don't realize there's a Lambda architecture at play underneath. I want to also talk about the different indexing. So in the demo, we only looked at inverted index, but as I mentioned, Pinot has a lot of different types of indexing, and there are each type of index will make certain use cases better. So for example, when you're doing an aggregation with a filter query, using a sorted or an inverted index gives you a lot of a speed up. So in this case, for example, the raw scan of data was more than 2 seconds, whereas these two indexes lets you query in terms of milliseconds. Similarly, we have a range index, which speeds up queries when you want to do a range filter query along with an aggregation. As I mentioned, we have a text index. So if you want to do regex text match on your Pinot data, you should configure a text index on those columns. And then finally, as I mentioned, StarTree is our most powerful index, and it speeds up even more as compared to the inverted index here when you're doing an aggregation. And this is because it's actually pre-computing some of the values without a combinatorial explosion of the value. So it's one of the most powerful index, which lets you tune how much you want to pre-compute and how much storage overhead you want in Pinot. So this is a comparison of Pinot as compared to the other popular open source technologies out there. I'm using Druid and ClickHouse for comparison. And as of now, Pinot definitely has a richer set of indexes that are available for your queries. In addition, the other things we added to Pinot, which makes it unique in this space, is ability to mutate data. Right. So upserts is interesting, right? For most analytical needs, people may not care about data mutation because whether the number of likes is 100 or 101, who cares? But in some cases, especially around business metrics, it's important to understand, to get an accurate view of your business metrics. And at Uber, especially, this was the case where upserting data in terms of the price of a trip or the number of trips or total revenue was very, very important. Right? And this was recently added and is now available in the open source. We also added a way to integrate Pinot with Presto, which is actually not very new. It's been around for a long time. It's actually quite popular as well. So with a Presto integration, you're now able to do full SQL queries on Pinot. Right? So things like you want to do joins or window functions, all of that can be done via Presto. And this is not with this integration, we are smart enough to push down most of the complexity into Pinot wherever it can be. So for example, most of the predicates and aggregation functions are actually pushed down into Pinot, and Presto does the bare minimum. I think I'll stop at this point since we went through a lot of things, and then we can stop for questions. Feel free to ask me to elaborate any of the points that we saw in the slides. Awesome. So I'll switch to the questions view now.
Hi.
So Mayank, I think, has already answered everything. I can probably log off. Just kidding. Thank you, Mayank.
Yeah, it's really great to see this kind of chats coming up in the chat. So just for attendees, because we have to wait for people to post, sometimes it takes a second to publish anyway. So if you have any questions for Chinmay specifically, feel free to post it now in the chat. But yeah, Mayank did a great job at pretty much tackling every question in there. So that's great. Thank you so much for the presentation, Chinmay. It's really awesome.
Sure. Thank you.
So yeah, if anybody has any questions, please post it now. Looks like we have some answers still being.
So there's some discussion happening on JSON index. So yeah, this was. I can talk a little bit about that. Actually, let me go back here. Yeah, so JSON index, right? This was, I guess, last year or maybe even a few years back. This was a sort of a limitation where if your input Kafka topic or input data has arbitrarily nested, the limitation was you had to flatten the data before it's ingested into Pinot. And this was quite common, and it's even common across other technologies. And it's complex because you need an additional framework to do the flattening. And typically, even at Uber, we were doing this, and we used Flink to do the flattening. Right? So while that works, it's an additional step, and it's an additional overhead that you need to maintain. So the JSON index was added to remove this limitation where it can directly ingest nested data structures. And then queries work on this nested schema also. So that's pretty cool. That was recently added. Okay.
Yeah, if there's so there are some other questions that came in, I
Okay.
think.
So I think we addressed the complex nested data type. Then can we automate the table additions than using UI? Yeah. So the Pinot controller, let me go back. It doesn't matter. Okay. So the Pinot controller has a rich API, which can be used for a variety of things. So it has API to create schema and then table config and then even modify this at runtime. So of course, you can use this API as part of your automation. Uh, Typically, this is done when you want to do like a CI sort of a stuff. So you create a new data set at runtime and then fire queries. So yeah, it's very convenient. Was there anything else that I missed?
I don't think so. I mean, we can give people another minute just to because sometimes it takes a minute to type out their questions. So if you have any other questions, please type them now, or anything that you want maybe Chinmay to elaborate on. This is a really good time to ask. And also, that doesn't have to end here. You could also join the Pinot Slack. I can post another link to the Pinot Slack. So you can always ask questions there. So Mayank, who's been diligently answering questions during Chinmay's entire presentation, will be there, amongst some other folks from the Star Tree team and Pinot contributors and community members and things like that are, very, very active and, and all this features and capabilities.
But I like StreamYard, by the way. It's handy. I wish they have a virtual background, so I don't have to worry about how messy my background is. Thankfully, today it was not.
So you do like StreamYard? I wasn't sure if it was
It takes a little getting used to, because since it doesn't let me share a tab, I have to share the entire screen. So you want to make sure your Slack is disabled and you're not showing your Slack messages while presenting. So those things, I think.
Yeah, that makes sense. Well, the cool thing about it is that we can start streaming. So right now we had just tried. Somebody just asked a question too.
Okay.
Kawai.
Yeah, Kawai Shang. Are servers memory or CPU intensive? What about brokers? Right. Yeah. So servers are memory and CPU intensive. Let me go back to the segment view. Yeah. So when we create, so first of all, when servers execute queries, they look at all these local segments and then the indexes that are created per segment. A lot of these, there's two ways to really configure this, right? You can either have configure an heap mode for your segment, so your indexes and everything sits in your JVM heap, or you can also have an off heap mode for your segments. So there's ways to configure how much heap you'll end up using per server. But the summary is, every time you're executing queries, it needs to get this index in memory for the respective segments that you're processing. And of course, with things where you need to do sorting and you need to do some sort of UDFs, computation is involved, and that also can spike up the CPU at times, right? So it is both memory and CPU intensive. Similar in terms for broker, I would say, and maybe Jackie can add to that, but for sure, brokers are also memory intensive. But since most of the computation happens on the server, I suspect the CPU is not as much. However, there are some things that the broker needs to do in case of group by, where it does need to process the intermediate results, and that adds to the CPU overhead. Mayank.
I know, I saw that. Let's highlight that. Oh no, that's the wrong one. Here we go.
Much appreciated.
Yeah, it's cool. All right, cool. So, I mean, I guess if there's no other
Yeah.
urgent burning questions, we
Yeah.
can
Did I
probably
go
wrap
too
it up.
fast? I wasn't sure. We still have. Usually we are right up at the 1 hour mark, but maybe I went too fast today. I'm not sure.
um, yeah, I mean, I don't think you did, but I also have seen this presentation multiple times, just being sharpened each time. It gets better and better.
So actually, since we have time and we have people, what would you want to see in a future intro to Pinot presentation?
That's a great question. Yeah, that's a great question. So, can you guys let us know if there's anything that you think specifically we could add to this presentation or elaborate more on? Um,
This is like real-time feedback from since
yeah,
we are a
real-time
real-time
feedback.
company.
That would make sense, right? To get real-time feedback, to use the time well.
And while people are typing, maybe do you want to also give a heads up on the upcoming talks, Kareem?
Yeah, so so a lot of these people are probably in the so here we go. Presto, Pinot, integration internals.
Yeah, good
That's a
point.
good one. Yeah. Um, so we do have a bunch of meetups coming up. Um, been starting in June all the way until August. Like every week there's like some kind of meetup about some kind of feature or capability or use case or something like that. So make sure you check out the meetup group. You can also, if you want to sign up for like updates on like events and stuff like that, well, I guess we don't really do it like, we're not going to be sending everybody like annoying emails about every event that we're having every week. So probably Meetup is the best way to do it, but you can add the meetups directly to your calendar, which I found out kind of recently. I haven't never done that. You can add the meetups directly to your calendar if there's anything that you want to see specifically, but there's a lot of really awesome content coming up. I'm assuming that most people here know about the Apache Pinot meetup just because that's where we posted this event. But I'll put the URL in there anyway. So yeah, somebody said some guidance around
Yeah,
capacity
that's a
planning.
great point. So yeah, I typically leave it out since that's an advanced topic, and I don't want to overwhelm people who are new to this, but I can definitely talk a little bit about that. So capacity planning is important. Let me go back to the yeah, this is fine. When we talk about capacity, there's multiple things you want to be aware of, right? Um, uh, in my opinion, I suppose the most important one is the memory that will be used on all these servers, right? So you want to be mindful of whether you're using heap memory or off heap memory. That's an important one. Um, and that often will lead to discussions around segment size and how many servers you would want for your given data set, right? So typically, the rule of thumb is um, for your given raw data, the columnar compression will end up somewhere between, let's say, 15 to 20% of the original raw data. And of course, this is just a rule of thumb. The actual can be different based on the cardinality and types of columns. But that's sort of a starting point for how much data you need to host. And then you would want to uh, understand, how many instances you want for your cluster. The minimum you would want is at least 2 for obviously availability. And then the guideline is start small. So start with only 2 or 3 servers, and you can always keep adding servers as you need. Right? There are some tools in Pinot that help you estimate capacity or size of a segment. They're also quite helpful. I want to say that as part of StarTree, we will also be providing advanced tooling to make this very transparent to our users. So people won't have to do it on their own. And this is one of the key things we're working on as part of StarTree.
It's awesome. That's awesome. One thing I would like to get some feedback from like some of the viewers and stuff is like even not just like for this event, like this meetup specifically, but like what content that they would want coming up next, right? So like if they're like, building up, but like, they decide they want to use Pinot, like what are the next steps, things like that. So like if any of you guys watching have some thoughts or feedback on what you would like to see next and like other types of content, please send me a message on Slack, on the Pinot Slack, and just let me know, because literally that's our job, is to like, well, it's my job, not everybody's job, but it's my job to make sure that you guys have the tools that you need to be successful. So like anything that you have, please share. Somebody asked if Pinot stores data on disk or passive data sets.
Yes. So as I mentioned, or maybe I did not make it more explicit. So Pinot does, the servers store the segments locally. So for example, let me maybe add a little bit more detail to this. So in case of a real-time data flow, when the servers are fetching data from Kafka, the segments are initially hosted in memory. And this, again, could be heap or off heap. At a certain point, the Pinot servers decide that we want to seal the segment, or basically commit the segment. And at that point, we convert the segment from in-memory to an on-disk representation. Right? So only the actively consuming segments are in memory. Everything else is actually sitting on disk. Right? So most of Pinot segments are actually sitting on disk. And every time you want to query it, we like do things like mmap the segment and then read the index and so on. So yes, you do need local disk. There are in the future we will be adding an option to host the segments which is not local to a given server. Right, so the segment can actually be remote, and that should still work with Pinot. Right, so that's coming up in the near future.
Cool. Awesome. So if nobody else has any other questions right now, but please, like I said, please join the Slack, and you can always ask questions there. And if you have any thoughts about what other kind of content you'd love, or because it's not just right, it could be you, but it'll be other people who also have the desire to have the same kind of content. So like, I would love to like make sure that we have that. So please just send me a DM and just let us know. But yeah, I think that's it. I think we could probably wrap up.
Awesome.
Cool.
Let me stop sharing. Okay, awesome. Thank you so much, everyone. Loved having you over. Right. See ya.
Thank you so much, Chinmay.
Bye.
Bye.